What is an inverse function and how can we find its derivative? That's what we're going to look at in this particular video, which is just a proof of the derivative of an inverse function. Let's go back and talk about the definition of an inverse function. Well, here's the definition. Let g of x be the inverse of f of x. Well, how do we prove that? It's when f of g of x gives you x back. Okay, so let's look at an example particularly of where that occurs. Let's say f of x equals x squared, and we want to prove that g of x, which equals the square root of x, is the inverse of f of x. Well, what we do is, we know f of g of x equals g of x squared. Now, why is that? Because here's f of x equals x squared, so f of g would just be taking x and replacing it with g, okay? Now, what is g of x? G of x is square root of x, so we're just going to replace this with square root of x. So every time there's an x there, replace it with square root of x. So it's square root of x squared, f of g of x, but we just get x back. So we've just proven that g is the inverse of f of x, and vice versa. Okay, now why vice versa? Well, if you did g of f of x and you plugged in g of f would be plugging in x squared here for x. Square root of x squared is just x. So we've proven that f and g are inverses of each other, and it makes sense. You know, one's x squared, the other is square root of x. Now the question is, now for the derivative of the inverse function, let f of x be a continuous and differentiable function. Let g of x be the inverse of f of x. The question is, how do we find the derivative of g of x? Well, fortunately, you know, you don't have to directly take the derivative of the inverse. And I know that kind of sounds weird. I mean, how could you figure out the derivative of the inverse if you don't take its derivative? Well, that's what we're going to figure out. Okay, there's actually a shortcut. So we know that f of g of x equals x according to the definition of the derivative. Let's take the derivative. So what we're going to do is take d dx of both sides, right? And notice we will be using the chain rule here. Because, and I'm actually going to just do this step down here, we will be using the chain rule because we have an outside function and an inside function. The outside function is f, so it'll be f prime of g. Okay, but then we have to take the derivative of the inside, which will be g prime. So we'll multiply that by g prime of x. And that's going to be equal to the derivative of x, which hopefully you recalled is just 1. Okay, so I messed it up a little bit. Let's try this again. So we have f prime of g of x times g prime of x equals 1. Well, notice we only have one thing left to do to get g prime of x by itself. G prime of x is the derivative of the inverse. That's what we want to show. So we just need to divide both sides of the equation by f prime of g. And that's what we're going to do. So let's go ahead and do that in our next step. Just divide both sides by f prime of g of x. All right, and what that's going to allow it to happen is it's just going to cancel this on the left, and we can see that g prime of x is going to be equal to 1 over f prime of g of x. So let's take a look and see what that's going to look like. All right, so we have g prime of x equals 1 over f prime of g of x. And notice, you know, you don't have to necessarily take the inverse, the derivative of g directly, okay? You can actually just plug the original function g into f prime, so you do have to find the derivative of f, and then do that under 1. So this is helpful when it's hard to take the derivative of the actual inverse function. And that's why you just use this shortcut, which is more or less a result of the chain rule. And remember, this works because g is the inverse of f. So if you're given a function f, this gives you the derivative of its inverse, g. Okay? Gives you the derivative of its inverse. And again, this is equal to 1 over f prime of g of x. So notice that we can figure out the derivative of the inverse of f of x without actually taking the derivative of the inverse. In other words, we don't need to do d dx of g of x. This formula will come in very handy when it's hard to take the derivative of the inverse. Okay, so that's it for our little proof of the derivative of the inverse, where g is the inverse of f. If you have any other questions about it, let me know.